at a physics question from the June 2019 examination. And the specific question that we'll be looking at is question 3, which speaks to heat capacity and latent heat. Now, the first part of the question 3a says that we are to define the term heat capacity. Now, heat capacity is the energy that is required to change the temperature of a body by 1 degree Celsius. So let's write that. The heat energy required to change the temperature of a substance by 1 degree. And okay? Now, the thing about this also, we need to remember that 1 degree rise in Celsius is equal to 1 Kelvin just the same. Okay? So therefore, we need not to be so worried about whether we use Celsius or Kelvin here, because 1 degree rise in Celsius is also equal to 1 degree rise in Kelvin. Okay? All right, so the next part of the question is asking us to define the term specific latent heat of vaporization. Okay, so what is the specific latent heat of vaporization? Now, this is the energy that is required to convert a substance from liquid to gas, right? So this is energy. No. So this next part of the question asks us to define the term specific latent heat of vaporization. Now, so this is the amount of energy that is required to convert 1 kilogram of a substance from liquid to gas at constant temperature. Okay? And this constant temperature that we are talking here is a boiling point. Okay? So let's go. At constant. And SI unit is joules per kilogram. Now, so what we also need to remember that when there's a change in phase, there is no change in temperature. Okay, so that is why at the freezing point and at the boiling point, the temperature of a substance does not change. So we need to remember that whenever we're doing these types of questions. Okay. Moving on to the next part, an experiment in which 1.5 kilogram of a substance at 30 degrees Celsius was converted to steam at 100 degrees Celsius. Assuming no heat is lost to the surroundings, calculate the amount of energy needed, 1, to heat the water from 30 degrees Celsius to 100 degrees Celsius. Now, so what is important for us to note here is that there's a change in temperature. And once there's a change in temperature, we will utilize this equation. E is equal to mc delta theta, okay? So what is m equal to? M is equal to the mass of the substance, which is the mass of water here, 1.5 kilogram, times the specific heat capacity of water, which is 4,200 joules per kilogram per Kelvin, multiply by the change in temperature, which is it was at 30 degrees and went up to 100 degrees Celsius. So therefore, the change in temperature there is 70 degrees Celsius. And why we can interchange Kelvin and Celsius here is because 1 degree change in Celsius is the same as 1 degree change in Kelvin. So let us utilize, so let us just eliminate some of the units now. So kilogram will cancel kilogram, and Kelvin and Celsius will cancel. So we are only left with joules. So therefore, when we multiply 1.5 times 4,200 times 70, so that's 1.5 times 4,200 times 70, then our answer there is 441,000 joules. Okay, so there's their answer. Now, the other part is asking us to convert the amount of energy that is required to convert water at 100 degrees Celsius to steam at 100 degrees Celsius. So at this point, the energy that is required, because there's a change of phase or a change of state, we are going to use the mass times the latent heat of vaporization. Now the mass of the water again is 1.5 kilograms multiplied by the latent heat of vaporization, which is 2.3 times 10 to the 6 joules per kilogram. And so when we multiply that, we get 3.45 times 10 to the 6 joules. Again, why we end up with joules? Because kilogram will cancel kilogram here. So therefore, if we were to calculate the total energy, so the total energy would be the energy in part 1 plus the energy in part 2. So let's just look at ET is equal to E1 plus E2, and therefore that would be equal to 44100 plus 3.45 times 10 to the 6, and then that would be equal to 3.89 times 10 to the 6 joules of energy. We'll be required to convert 1 kilogram of water at 30 degrees C to steam at 100 degrees Celsius. And this is how we would have approached these types of questions. Again, whenever we get these questions to do, once we have we know the basic concepts, we just need to remain in the question, because by remaining in the question, the answer will come. What does that mean? It means that there are some of us, the moment we see a particular question, we give up because we do not understand it fully. But I am imploring you to stay in the question, stay with the question. The answer will come. Have a blessed and wonderful afternoon.